Hey guys, Mr. Yisley here. So we're on to lesson number 21, which is all about perfect square trinomials. And so these are another form of a trinomial that follows a specific pattern. And we've talked about these actually from the reverse side before earlier in the chapter. So now we're going to talk about how we recognize them and factor them very quickly using a little bit of cheat codes like we've talked about before. So a perfect square trinomial is going to look something similar to this, right? It's going to be a squared or a perfect square up front plus 2 times something plus b squared, right? So there's an example like that. Now, when we have a perfect square trinomial like the example there, all right, we're going to end up with a binomial inside of our parentheses with a squared outside of it. Now, it could be a positive one or it could be a negative one, right? In terms of it could have a plus sign or it could have a minus sign. Both of those are possible options, right? So don't be discouraged if your B has a negative on it, right? That's okay, right? We can figure that out as we go. So let's take a look at some examples and figure out how do we recognize this, or how did we actually end up here. So before, again, we've talked about how we can factor these using the AC method. So I'm going to, out here to the side, deal with this first one using the AC method. So x squared plus 6x plus 9. So again, first we would check for a greatest common factor, all right, which we don't have. So then we would do a times c. And a in this case is, of course, 1. So 1 times 9. So we're multiplying those. And we would get 9. Then we would find the factors, which are 1 and 9, and then 3 and 3. Now, once we're here, we would then figure out, all right, which one of these is equal to b. All right, well, it's a positive b, so plus 6. And I noticed that if I said 3 plus 3, that would equal 6. So that would be the one I would use. So then I would go break this apart. So we would have x squared here. The middle term breaks into 2 terms, which would be plus 3x plus 3x. Last term comes down, so plus 9. Then we would go into our grouping method like always, and we'd factor the greatest common factor out of the first group, so which this in turn is x. And we would say, all right, what did I multiply x by to get to x squared? Well, that's x. What did I multiply x by to get to 3x? Well, that's positive 3. Then greatest common factor of the second grouping is, again, positive 3 here. So then what did I multiply positive 3 by to get to positive 3x? Well, that's x. What did I multiply positive 3 by to get to positive 9? That's positive 3. And so then we see same parentheses here. So we've got x plus 3. Then we would bring down, same parenthesis here, which is x plus 3. So our 2 parentheses are the exact same. So when we recognize that, we would go, oh, okay, well, I can write that as x plus 3 squared. And that would be my final answer. Now, what I want to point out to you, and the way we can recognize this, right, that we have a perfect square trinomial going on, right, is you may have noticed as we were factoring that, right, what we ended up with was 2 of the exact same term here in the middle, the plus 3x and the plus 3x. And that's because when we divide this by 2, it comes out perfect here, right, where we're going to have the exact same number on both sides. Other things that you might have noticed, all right, is that x squared is a perfect square, as is 9 is a perfect square, all right? And that is our indicator, all right? If our first term here, all right, is a perfect square, and our last term here is a perfect square, we have a potential perfect square trinomial. The indecision is that we need to know is, if we divide the middle term by 2, would we come up with the exact same term on both sides? Would we end up with, in this case, positive 3x and positive 3x? If you will, then you have a perfect square trinomial. So what we can actually do in order to figure that out is we can just check those things really quick. The first one, the third one, are they both perfect squares? Yes, they are. All right, and if that's the case, then does the middle one divide evenly by 2 to come out with 2 of the exact same term? So when we recognize that, right, then we can go into the cheat code, and we don't necessarily have to do the AC method. Now let me preface before we go into these examples, you can use the AC method. I showed you how you get there, all right? And that's completely fine if you do that on your assignments or on your quizzes or tests, all right? Now if you notice that it's a perfect square trinomial and you can go through this quick way that I'm about to show you, then that's fine as well too. For the notes, we're obviously going to show you the quicker way. So let's take a look at example A. I've got n squared plus 8n plus 16. So when I look at this, all right, I notice right away that the first term is a perfect square, as is the last term. It is a perfect square as well, because n squared means n times n, and the last term, 16, means 4 times 4, all right? Now, so then the last question I need to know is 8n, if I divide it by 2, am I going to get 2 of the perfect or the same, all right, term? Right? So if I divide this by 2, I know that I'm going to come up with 4n and 4n, and those are just being added. Well, if I know that, then I already know what my parentheses are going to look like, right? Because this part really doesn't matter anymore because they did come out perfect. So I'm going to have one parentheses, right? And the way we determine the sign of that parenthesis, all right, that's going to be in there is this right here, right? This plus sign that is right there. So when I figured that out, all right, then I need to put that down here. So we've got a plus right here, right? So then I put n over here, right? And then I put the 4 right there, and I end up with the squared right here. So n plus 4 squared would be the factors of this perfect square trinomial.